Welcome. This unit is, or this lesson is PreCalculus Unit 1, Lesson 2. It's a review of algebra, and really the content is vast because algebra is a very large topic. There are many things that you've learned in this, but I'm going to point out some of the more important things that you need to remember. One of the things that gives people trouble, for example, is working with exponents. Working with square roots and so forth and such. One of the things that is really important to understand is the meaning of exponents when we're not dealing with whole numbers. So square roots, so if for example, if I have the square root of x, that is the same as x to the 1/2. Okay. If I have the square root of x to the 4th, or the square root of x to the 3rd, that is the same as x to the 3/2. Okay, so basically that square root becomes a 1/2. The 3 becomes the numerator of the fraction. Okay, another one here. With let's say I have the 4th root of x to the 5th. That would be x to the 5/4. So hopefully that makes sense. All of the rules of exponents apply. So if I have x to the 1/2 times x to the 2/3. That's the same as x to the, and in this case, when you multiply same bases, you add the exponents. 1/2 plus 2/3 would be 3 plus 4 over 6, which is x to the 7/6. Or you could say the 6th root of x to the 7th. Okay, so all the rules of exponents apply even though you're dealing with fractional exponents. So that's important to remember. Now that aside, let's go ahead and get into some problems that you're going to be needing to be able to do. So I'm going to make some stuff up. So 4x, let's say 4x times x squared plus 5 minus 2 times x plus 7. Okay, so you recall to simplify this expression, you use the distributive property. Multiply 4x, multiply 2. Hopefully this is review and very familiar. 4x to the 1 times x squared is x to the 3rd. Add the exponents when you multiply same bases. 4 times 5 is 20x. Don't forget the negative gets distributed with the 2. That's a common error. Negative 2x, negative 2 times 7 is negative 14. Combine any like terms, we have an x cubed, so that's the only x cubed, 4x cubed. And combine the x's, negative 20x and negative 2x, combined together, those are like terms, is 18x minus 14. Okay, so that's about it for that particular type of problem. There's another kind of problem you might run into here. Let's say we have 4x squared y to the 7th to the negative 2nd times 3x y to the negative 3rd. I'm going to make this complicated here. Over, if I can draw a straight line, over 2x to the 3rd to the 4th, y to the negative 3rd. All right, so we're going to use a bunch of stuff. Okay, so first of all, we use the distributive property for exponents, which says basically that we can take the negative 2 outside the parentheses and distribute it to any factors inside. Note those are factors, things that are multiplied, not things that are added. Don't ever let me catch you doing this. X plus y to the 2nd equals x to the 2nd plus y to the 2nd. That is wrong. Okay, don't distribute the exponent over addition or subtraction, but you distribute exponents over multiplication, over factors. Okay, and so we're going to distribute that, and I'm going to distribute this as well. Right, so we've got 4 x to the 2nd to the negative 2nd is x to the negative 4th. Right? Power to a power, you multiply the exponents. Y to the 7th to the negative 2nd, negative 14. 3x y to the negative third all over. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. X to the third to the fourth, power of powers, is x to the 3 times 4, 12. Y to the negative third. So there we have that. Okay, we might do as a next step multiplying the coefficients. 4 times 3 is 12. X to the negative fourth times x to the 1. Think of combining like terms or like factors here. X to the negative fourth times x to the 1 is x to the negative third, because negative 4 plus 1 is 3. Okay, and we're going to do the same with the y's. Y to the negative fourth times y to the third is y to the negative 14th is y to the negative 17th. All over 16x to the 12th, y to the negative third. Okay. Next thing I'm going to do, and there's some freedom in the steps you use, but I'm going to reduce 12/16. They both reduce by 4 to 3/4. Okay. So let's do that here. So 3 on the top, 4 on the bottom. Okay, x to the negative third, I'm going to move the negative exponents across the bar. When you move a negative exponent with its base across the bar, it becomes a positive. So y to the negative 17th is going to go down. Y to the negative third is going to go up, just to make them positive here. 3/4, let's see. On the top is going to be y to the third. On the bottom is going to be x to the 12th, it's staying put. X to the third, y to the 17th. So when a base or a power moves across the bar, it changes signs. And one last step, combine the like factors here. Y to the third over, well, actually 2 more steps. X to the 12th, x to the third is x to the 12th plus 3, x to the 15th. 4x to the 15th, y to the 17th. And I should have done that in the same step. Okay, so when you have a variable on top and bottom and want to simplify an irrational expression, what I do is I take the one with the largest exponent, I keep the y there. So 17 is bigger than 3. 17 take away 3. The quotient rule says to subtract the exponent. 17 take away 3 is 14. And there we have it. Okay. Not the only sequence to do it in, but those are some of the rules of exponents that you want to review and make sure you're comfortable with. Okay. Then another topic that was treated in extensively in this lesson was the quadratic equations. So I'm just going to make one up. That's kind of dangerous to do, but let's see if it works here. X squared plus 5x minus 4 plus equals 5x squared plus 2x minus 7. Okay. So when solving a quadratic equation, this is quadratic, I know, because it's polynomial, and so it's got powers of x, and each term has a coefficient, a power of x. Even the constants have a power of x. It just happens to be x to the 0. All right. So it's a polynomial equation, and the highest ordered term is 2. So this is a quadratic. We solve quadratics by getting it into standard form. That is, we're going to get everything to one side. So I'm going to subtract 1x squared from both sides. I'm going to subtract 5x from both sides. I'm going to add 4 to both sides. And then I'm going to switch the order. I'm going to do that all in one step. So 5x squared minus x squared is 4x squared. 2x minus 5x is negative 3x. Negative 7 minus 4 minus negative 4. Negative 7 minus negative 4 is negative 7 plus 4 minus 3. Equals, and since I subtracted all of that out, the left side is 0 and it's going over here. Okay. So hopefully that makes sense. Let me know if you need any help. So now we have a choice. There are three different, actually, well, there's more, but there are generally three approaches. Factoring. You spend a lot of time learning to factor in Algebra 1 and Algebra 2. Factor. Quadratic formula. And actually I'm going to insert this other technique in the middle. Complete the square. And quadratic formula. I put them in that order because the quadratic formula actually comes from completing the square, so they're pretty much the same technique. But in pre-calculus, you're going to need to be able to do that. Now, factoring, the approach I use here is I write two pairs of parentheses, and I use a little bit of a guess and check. Now, the technique I use or the way I write things is kind of unique to me. You may have your own system, but I think of things that multiply to make 4. That's 1 and 4 and 2 and 2. Things that multiply to make 3, 1 and 3, and I think of combinations. Since there's only one choice for here, I'm going to go with 1 and 3. Okay. Now I'm going to guess and check and see if we can make things work over here. So 2 and 2, and the way I check is multiply the middles and the outsides. And they should subtract to make 3. Unfortunately, the difference between 3 and 2 is 1, so that combination doesn't work. I can try switching the order, but 2 and 2, switching the order is still 2 and 2. So let's try 1 and 4. 1 times 4, 1 times 3, difference of 1, doesn't work. And switching the order, 4 and 1, 1 and 12, difference of 11. So lo and behold, I've gone through, I've exhausted all the possibilities for factoring, and there is no whole number solution for factoring. That actually is the case more often than not. If you make up a random quadratic equation, most of them won't factor like this. And so we're left with completing the square or the quadratic formula. I'm going to complete the square. Completing the square involves moving the constant term to the other side. And 4x squared. And I know I'm going fast because really we're covering a lot of material in a short amount of time. You're going to get all this in the lesson. So 3 to the other side. Okay. And then this is kind of a tricky step. You don't always have to do this, but we have a coefficient on the x squared term. And so what we need to do is we need to get rid of that. So I'm going to divide everything by 4. So 4x squared divided by 4, 3 divided by 4, and 3 divided by 4. Okay, so we get rid of the leading coefficient on the x squared. It needs to be 1. Okay, and now what we do is we take 3/4 and we divide it by 2, and then we square it. Now there's a reason why we do that. Basically, what we're doing is we're thinking what multiplies, or what adds to make 3/4. What plus itself adds to make 3/4? Well, the answer is 3/8. And particularly negative 3/8. Negative 3/8 plus negative 3/8 makes 3/4. Okay? And by the same token, this last term is now going to be the product. Negative 3/8 times negative 3/8. So I don't know if you've ever thought of it that way before. But what number added to itself makes this term? Now multiply that number by itself. So that's where we get half and squared. Completing a square. It's writing the term that makes it a perfect square. So negative times negative is positive. So we're going to add. 3 times 3 is 9/16 plus 9/16. Okay, and anything I add to the left side, I add to the right side. What this does is it makes the left side a perfect square. It makes it x minus 3/8 squared. X minus 3/8 squared. And now all I have to do is do 3/4 plus 9/16. Little fraction arithmetic. 4 times 4 is 16. 3 times 4 is 12. So 3/4 is 12/16. 12/16, and 9 is 21/16. Okay, and now we've got a single x, and now we can just solve by undoing. So think of the opposite of squaring, which is square root. X minus 3/8 equals the square root of 21/16. And then when you square root, there's a positive and a negative answer, right? Positive and a negative answer. Square root of 9 is 3, but also negative 3 is a square root of 9 because negative 3 times negative 3 is positive 9. And we can square root the numerator and the denominator of the fraction separately. So I'm going to say square root 21, and square root 16 is 4. Okay, and now we're just going to add. So x equals 3/8 plus or minus square root 21 over 4. And there we have it. So that's the exact form, and you can use a calculator to give me 2 decimal answers here. Okay. So on the same screen, I'm going to use the quadratic formula, and I want to show you how they really are the same thing. One comes from the other. Okay. So let's switch to yellow here, complementary colors. All right. So let's start with down here. Let's start at this point. 4x squared minus 3x minus 3 equals 0. You may recall the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. If you haven't memorized it, memorize it. Negative b plus or minus square root b squared minus 4ac all over 2a. A is 4, b is negative 3, and c is negative 3. So now by substituting we get x equals negative 3 plus or minus square root negative 3 squared, okay, minus 4a, 4, times c, negative 3, all over 2a, 2 times 4. Okay, and you can use your calculator. In fact, that's perfectly legit to do here. But do realize that if you want an exact answer, you're going to still have to work it out in steps. Okay, so 3 plus or minus 9. 4 times 4 is 16. 16 times 3 is 48. So plus 48. All over 8. You may recognize some similarities between what we have here. I see the 3/8 right now. Okay. And x equals 3 plus or minus 9 and 48 is 57. And actually, is that right? Did I do that right? 4 times 4 is 16. 4 times 4 times negative 3. 4 times 4 is 16. 16 times 3 is 30, and 6 times 3, 18. It's 48. 48, and 9 is 57. Yep. Okay, divide by 8. Square root 57. The reason I'm wondering is I'm not sure I'm getting the same answer. Okay, so let's see. Square root 57. 57 goes by 3. 27 is 9. 3 times 19. Yeah, I'm not getting the same answer. So that tells me I may have made a mistake somewhere here. Add 3. Boom. Yeah, good on that step. Divide by 4, negative 3/4, 3/4. Okay. Half of 3/4 is 3/8. 3/8 squared is 9/6. Oh, boo, there it is. 8 squared is 64. There's my problem. 64. So it's no good from that point forward. This is what happens when you're not careful. But Modeling how to problem solve. Finding your mistake. 8 squared is 64. 64. There we go. All right. X squared minus 3/8 quantity squared equals 4 times 16 is 64. 64. 3 times 16 is 30, 48. There we go. There we go. And 48 plus 9 is 57. There we go. 57, 64th. Square root of 64 is 8. Actually, hold on. I'm not there yet. Now, x squared minus 3/8. Boom. Square root 57 plus or minus square root 57 over 8. Okay. And add 3/8. X squared equals 3/8 plus or minus root 57 over 8. And there we go. Same answer. Okay, you can break up the addition over a common denominator. So this is equal to 3/8 plus or minus square root 57 over 8. Yeah, all right. So that's kind of a review of some of the major concepts you need to be familiar with. Completing the square is especially important, so pay close attention to that, and let me know if you need any help.